All right. Hello, everyone. How are you all doing? So, today I have got a lecture for you, and this will be basically on the topic of differential equations. So, in today's lecture, we're going to be seeing that how we can solve problems for your CBSE examination, that is upcoming the examination. Hello, everyone. How are you all right doing? So, I hope I'm audible to every one of you, and fine. So, it's a wonderful opportunity to basically be back on this part, and we will basically discuss about the topic of differential equation. Okay. Now I have seen people basically having difficulty to study the differential equation part, right? So in this particular lecture, I will be solving some of the important previous year problems of from CBSE board examinations, and I will make you to show that these problems are neither difficult, rather they are more of like conceptual. If you understand the concept for the time being, then it is fairly simple task. Fine. So my try will be basically to discuss all the important part so that it's easier for you to also understand as well as to work upon. All right. So just gives a thumbs up if you are all ready to start with. Just a thumbs up would be enough. Fine. I hope I'm visible to all of you. Okay, so my name is Sirsha and I will be the instructor for this part. Alright, so today's goal is basically to discuss about the some of the important topics from integrals. Like along with we solve the questions, we will be basically visualizing how we also utilize the part of integral. Fine, and also we will see how to different methods of solving a differential equation. So most likely you will be having or encountering the questions from like simply which are like variable separable from, or either you will be encountering questions which are like of the homogeneous equations, or you might be encountering forms of the first order linear differential equations. Alright, so today's lecture I will basically focus on the solution part of the differential equation, because the part of the differential equation where you have to basically determine the order or the degree of the differential equation or the formation of the differential equation, those are fairly simple, and I think that is basically doable for every students. But in this particular lecture our focus is more on to solving differential equations. Also, along with that, I will be showing you what are the graphical representation that a differential equation is basically trying to imply. Fine. So, and then after that, we will be having some paper analysis so that to explain you that how can you strategize your preparation as part to the calculations. Okay. So here is the very first problem on the screen to all of you, right? So if you just look at the problem, you can all just look at the problem, and whenever you will have a differential equation problem in an examination, now I will be showing you how you are going to represent that in the actual exam, right? So I'm writing over the solution over here. So before we move to the solution, let us quickly revise what's a differential equation. Well, in the chapter of functions, you must have seen that a dependent variable was a function of some independent variable. This is what we have seen in the function, right? So differential equation is nothing but an equation of a polynomial form where instead of having the variate as x, we are going to have the variate as the differential forms of the dependent functions. Fine. So that is what basically you will be seeing some equations which will contain some derivative. Like I'm putting second derivative as double dash, first order derivative as one dash, and something as y. And when this particular equation is equal to some quantity, then we call this kind of equation as a differential equation. It is clear, all of you, right? So, in this particular problem, let us first of all go through the problem. So if we try to read the problem, what we understand, so if we try to read the problem, we are going to see that the question is talking about we have to find a particular solution to the differential equation which is given other form. So whenever you are going to encounter this problem in the examination, how we are going to write it, I'm going to show you over here. So first of all, you should definitely mention the given differential equation. Given differential equations, right? So your very first task is to mention given differential equation. Now, I would also recommend all of you to please do not use short form or abbreviations in your CBSE board examination. While you're practicing, it is fine, but when you're actually solving for the real examination, please do not use abbreviations. It actually takes away the professionalism in your answers, okay? So make sure to note that. So first of all, you will write the given differential equation that is mentioned in the problem. So your differential equation is given as dy by dx is equals to 1 plus x plus xy plus y. Now looking at this problem, you're having no clue on how to proceed, right? So and also you have to mention that the given conditions, these conditions like y is equal to 0 when x is equal to 1 is called the boundary value problem, or we also call this kind. So if you are thinking that your x has a boundary or your particular solution of the equation has some boundary, then we call this as a boundary value problem, right? But we are provided with one particular value since we have only two unknowns, right? X and y. So with that we can basically find it out. So what is basically mentioned is that given y is equal to 0 when x is equal to 1, this is mentioned just to calculate the constant part of your differential equation solution, right? So if we look at this particular differential equation, what we see is that we are getting the differential equation something of dy by upon dx is equals to x plus 1. Now if you look at this part, you can take y common and you can easily write it as y times of 1 plus x. Fine. Now, if we proceed further, what you will do is that you can definitely mention dy upon dx is equals to. So, from this particular right hand side, what I can see, I can take x plus 1 as common. So, if I take 1 plus x as common, I will be left out with 1 upon y. Now, the problem is very simple and straightforward. As you can see, it is basically separated out in the two variables, right? So, x part is separated with the x part and y part is separated, and it is separated as a function of the individual part, right? So what you can do, you will basically need to solve it by the help of variable separable method. So if we look at it, how to variable separable, so I will be solving it, then you will be using solving it by variable separation method, because we can easily separate the variable into the corresponding derivative, right? So variable separation method, then what you can do, you can proceed with the y part on the y side. So I will take dy divided by 1 plus y with the y part, and I will keep the 1 plus x with the dx part. Now if you integrate both the sides, if you just integrate both the sides, so I will write integrating both the sides, right? So if we integrate both the side, what we find out that we are going to get over here natural logarithm of 1 plus y is equals to, this part is going to give me x plus x square upon 2 plus some constant, right? Now in order to calculate the value of the constant, we are already provided with the initial condition, that is y is equal to 0 when x is equal to 1. So what will I do? I will just put the value of x equal to 1 and y equal to 1 to get the value of constant. So if I put the value of x equals 1 and y equals 0, what I'm going to get, so this part is going to be natural logarithm of 1, which is equals to 0, and this part is equals to 1 plus 1 by 2 plus c. So from here I'll get the value of the constant as minus of 3 upon 2. Fine. So from here I will get the particular solution to the differential equation as, so therefore our particular solution to the differential equation will be given as log of natural logarithm of 1 plus x 1 plus y is equals to x plus x square upon 2 minus 3 by 2. Right. Now you can further simplify it as, you can take y plus 1 is equals to e raised to the power this part, right? So I'm writing it over here, minus of 3 by 2, and you can further simplify it as, right? So I can further simplify and I'm writing the answer over here. So the ultimate particular solution you're getting is y equals 1 minus e raised to the power x plus x square by 2 minus 3 by 2. So that is going to be a particular solution to this particular differential equation that you are having. Fine. So I hope this question was clear enough. Right. So I am again breaking down the question again. So first of all, when you are solving for the differential equation, your step-by-step methods are as follows. That first of all, mention clearly what is a given differential equation. Once you mention your clearly differential equations, then your task is basically to solve upon the part of this variable separable part. And once you separate the variables into two parts, then you have to proceed with the integration on the given condition that x equal to 1, y is equal to 0 with this particular initial condition. So I'm writing this as initial condition. Fine. Now I will explain you what is the mass distribution you can expect it. So whenever you will solving the problem, so this is with respect to the mass distribution, is that if you are able to solve it till this particular step, you are going to get 1 marks. After this, so this particular step you will fetch you 1 marks. It's total of 3 marks problem, and if you can solve this part, you will get 1 marks. Then for integration of this particular part, you will get 1 more marks, and finally for putting this initial condition and getting out the value of c, you are also going to get 1 more mark. So that will be your marks distribution. So in examination, when you're actually solving this problem, please make sure to write the question properly, solve it step by step, get to the values of the constant step by step. That will actually help you in fetching the full marks in this particular problem. So I hope you can see that how easy this particular problem is, and with this particular problem you can understand that you are mostly going to encounter easy problems in your examinations. Fine. So this is the first problem of your CBSE board examination from the year 2014 that I have taken up to just illustrate that the problems are fairly simple. The thing is that you have to actually apply your IQ in order to get to this. Fine. I hope this particular part is clear. If you have any queries, you can put that up on the chat box. I am seeing that. Okay. If not, then we can proceed with the next problem. Fine. Again, we have a problem where we have to find it out the particular solution to the given differential equation. Now, by looking at the differential equation, it might seem very difficult at the first of time, right? But I have given you the thing that you can see, like if you look at these dates, you can see it has been repeated in 2009, 2011, 2014 and many more times, right? So the book from where I was basically taking this question, it was mentioned as this particular part has been repeated, right? And it is generally seen that in examination also these types of problems are generally getting repeated. So it is a very much of advantage that if you just understand the problem that I'm doing, you are mostly going to face the similar type of problem in an examination as well. Fine. So I will be showing you how we are going to write it down in your actual CBSE paper, right? So first of all, when you have this particular question that you have to find the particular solution to the differential equation, first of all, you will mention given differential equation as. So it is very simple and straightforward to all of the problems. So first of all, you should mention the given differential equation. Sorry, I mentioned that as solution. So first of all, you should mention the given differential equation. Fine. Now again, please don't use abbreviations in your actual paper because that will fetch you less marks. Okay, so please keep sure in that thing. Okay, so the differential equation is given as x times of dy upon dx minus y plus x times of cosec y upon x is equals to 0. So that is our required given differential equation, right? So if we try to simplify this part, what I can do, I can take x common from this part and I can write this as dy upon dx minus y upon x plus cosec times of x upon y, sorry, y upon x. Is it clear to all of you? And that I can equate it with equal to 0, right? So our differential equation can be easily written like this. Now if you look at this particular differential equation, it is basically of the form of homogeneous differential equation, right? So I'm writing in short form. I hope you understand, right? So it is a part of homogeneous differential equation. Now why it is homogeneous? Because you can see that y by x and this particular form is coming up in the variate, right? So it is beneficial that if we see that how to solve the homogeneous differential equation is that now what we can do is let us assume this y upon x part as some constant v. Fine. So let us assume this y upon x terms as some variable, not a constant, it's a variable v. And then the advantage of doing this is basically is that I can write y as v times of x. Now if I differentiate both the side with respect to x, I can easily write this as dy upon dx is equals to v plus x times of dv upon dx. So for differentiating this part, I have just used the part by part product method, right? So for differentiating this is the product rule. I hope you know, right? First considering v as constant, differentiating x, and then considering x as constant, then differentiating v. Fine. So with this, if I try to proceed it, what we are doing is basically, so in place of dy upon dx, I am putting v plus x times of dv upon dx. So if I put that in the differential equation, I am going to get it as v plus x upon dv upon dx minus minus so if I take it on the right hand side is equal to v minus cosec v, right? As simple as that. Now you can see that the v and v get cancelled out from both the part, and now the beauty of this particular homogenization method is that the ultimate differential equation get reduced to the form of variable separable part. I hope this particular part is clear. So from here you can see that it is variable separable as dv upon cosec of v is equals to minus of dx, right? So as simple as that, right? Also don't forget there is one more x over here, so it is 1 upon x, right? Now from here you have to do integrating on both the sides, you will get the required solution for the differential equation. So 1 upon cosec v is basically equal to sine v, and integration of sine is basically of minus of cos v. Minus of cos v is equal to minus of natural log of mod of x plus some constant c. Now, in order to get to the value of constant, I have given the condition that initial condition y equal to 0 when x is equal to 1 again. So I will write it again as initial condition, that is y is equal to 0 when x is equal to 1, right? So if you just put this particular condition y is equal to 0 when x is equal to 1, you will basically fetch the value of constant c. Now you know that v is basically equal to y upon x, right? So this particular part is going to be equal to minus of 1, this particular going to be equal to 0. So from here you will get the value of the constant as equal to minus of 1. Fine. So once you get to the value of the constant as minus of 1, so what you can do, you can just keep it back into the formal equation, and therefore your final solution is basically cos of y by x is equal to natural log of x plus of 1, right? So I have taken the minus 1 in common from the all the part and I have cancelled out, right? So from here you will ultimately get the solution of this particular form. Now it is always recommended to represent the solution as y equals some part of x, right? So for doing that, I can definitely write the solution to this is basically equal to y equals to x times of cos inverse of natural log of x plus 1, right? So this is going to be our ultimate solution. So this is going to be our ultimate solution, right? So whenever you are actually doing the problem in your actual examination, please mention to solve it step by step, okay? And it is always preferable to not leave the answer in this form, rather to solve it by evaluating y as terms of x. So here the y is basically in terms of x as x times of cos inverse of natural log of x plus 1, right? So this is going to be a recurrent solution of the differential equation. So if you are basically doing all these steps correctly, then you are definitely going to have the full marks in the problem. So this problem was basically a 4-marker problem. So what you can expect is that at each and every step that you are doing, so for this particular step you will basically be granted 1.5 marks. For this particular step of integration and putting the value of the constant, you will again get 1.5 marks. So that basically fetches your 3 marks. And for writing the ultimate solution with the value of the constant, you will again get 1 more marks. So if you are doing all these steps correctly and clearly, then you are going to definitely get the full marks in this particular problem. I hope this problem was very simple and straightforward. Fine. If you have any queries, you can please put that on the chat. You can let me know if you have any query. Fine. So with this part, I am moving forward with the next problem. If you are having any query, you can stop me and you can tell me about any query you are having, right? So I'm just looking at the chat, but there are none. So I'm proceeding with the next problem, right? So if you look at the next problem, what you can see is that we again have a one more differential equation. And now, so if you're looking at the questions that I'm taking side by side, this that I have taken one problem from the variable several part, I've taken one problem from the homogeneous part, and now this is something different from the parts that have been seen. Now this is a very important form. Now it is not only important for your CBSE board examination, as well as it is important for your JEE mains examination, right? So some students who are basically preparing for JEE mains along with your preparation, you can definitely focus on the first order linear differential equation, right? So if you look at the problem again, so again I will write the steps that given differential equation as, so I have the given differential equation as x times of natural log of x dy upon dx plus y is equals to, plus of y is equals to 2 upon x log of x, right? So that is the given information to us, right? Now in this case we don't have to calculate the particular solution of the differential equation, rather we will solve it as a functions y in terms of x plus some constant. Now in this particular solution I will explain you that what is basically mean by the graphical representation of a general solution of a differential equation, right? So let us see, first of all, let us try to understand it. What is basically meant by this problem is that, so if we try to separate some of the or simplify it, we can simplify it as dy upon dx plus so what I can do, I can write dy upon dx plus, now if I take this x log x common from the equation, so I can write this as y times of x upon natural log of x divided by 2 upon x square. I hope this step is very simple and clear enough, right? Now, what is the advantage of doing this is that you are able to see that this particular form is very similar to that of the first order linear differential equation. So, if I recall that the linear differential equation of first order, that is of the form dy upon dx plus p times of y is equal to some q, where q is a function of x as well as p is a function of x, right? So this is basically of the form of the first order linear differential equation. Now if we have this particular form of first order linear differential equation, so from here I will get the p of x is basically nothing but 1 upon x natural log of x. You can just follow from here, right? So now in order to solve a first order linear differential equation, you need to have information about the integrating factor. So what is the integrating factor? So you have to write it step by step also. So integrating factor for the first order differential equation is basically given as e raised to the power integration of px dx. Fine. So from here what you will get the integrating factor as e raised to the power integration of 1 upon x log x dx, right? Now our task is basically to solve this particular integrating factor. Now if you look at this particular integration that is present here, so if you see, if you take log of x as some as some variable, so we can definitely solve this integration in the power part or the upper index easily by substitution, right? So I will do the substitution easily, that is I can assume log of x as some t, so therefore 1 upon x dx is basically equal to dt. So therefore your particular your integrating factor is basically e raised to the power integration of e raised to the power integration of, so it is basically going to be dt upon t. Fine. So therefore your particular integral is going to be equal to e raised to the power ln of t. Now here we don't put the constant, because if you even put the constant, that is going to be separated out and goes to the ultimate constant that you are getting from the solution of the differential equation, right? So therefore this can be written as e raised to the power natural log of x, right? So now if I use the base changing property, that is a raised to the power b times of log c, so that is basically equal to c raised to the power. So this is basically easily written as c raised to the power b natural log of a, right? Even if we have the base as same, that actually matters, right? So we have to have the base same, right? So this particular property is called as the base changing property. So if we apply the base changing property over here, we are going to get the integrating factor as natural log of x, right? Now your ultimate solution to the first order linear differential equation is basically y into integrating factor is equal to integration of integrating factor into q of x dx, right? So if we just solve it, we get the solution as y into natural log of x is equal to integration of 2 upon x square natural log x dx. Now your part is basically in to solve this particular integration. So in order to solve this integration, I will take the help of by parts rule. I hope you know how to solve an integration by parts, right? So this problem is a lengthy problem. You can see that we have to again solve for the by parts, right? So I will just erase this part. So I will just erase this part and I will solve the by parts over here. I hope you are copying down. So from this part, so from here, if I just proceed further with the by parts solution calculation, so what I will see, it is basically log x. So this is going to be my first function, this is going to be my second function, right? So I hope you remember the rule, that is Euler rule, right? So according to Euler rule, which said the first function and the second function, so that is going to be first function into integration of the second function, and that is easily as minus of 2 upon x minus integration of differentiation of the first function, that is going to give me 1 upon x into integration of the first function, that is going to give me, sorry, second function, that is going to give me minus of 2 upon x dx, right? So your ultimately this particular integration will be simplified as it is going to be equal to minus of 2 upon x log natural log x minus, now this part is simple, this is going to be again be equal to minus of 2 upon x plus some constant, right? So therefore your solution the differential equation is basically equal to y into natural log of x is equals to minus of 2 upon x log x minus of 2 upon x plus some constant. So that is your required solution to the given differential equation. So whenever you are seeing the question, please make sure to ultimately write the answer properly and mention all the steps clearly so that you can get the full marks on the question, right? So this question was a 4-marker problem. So as you can see, this part was little bit lengthier, not difficult, but very simple, right? So now I was discussing about what is the role of this particular C. Right. So in differential equation problem, when we are solving for the differential equation problem, the solution of the differential problem is basically representing the family of curves. So basically this based on the constant value. So for example, if you have a curve like this for this particular solution, so based on the different values of C, the curves will either shift up or shift down, right? So you will be having some family of curves with following the same criteria or same differential equation. Only thing is that their initial value is different, right? So you can see from here, rest they are following the same differential equation, as you can see. So therefore they are originating from the solution of the same differential equation with the certain given different constant value, which will determine the initial condition. Fine. So I hope this part is clear up, right? If you have any query, you can put that on the chat. I'm just looking at your chat. You can tell me about your queries. Fine. So I hope this part was clear enough, right? Now with this, let us move to the next problem. Now next problem is again a question of homogeneous differential equation, right? So again, So the process will be very simple. So again you have to solve it with the given condition, but here we have to not find the particular solution, rather we need to find the general solution. So we will read the answer in terms of the constant C, right? So first of all I will write it over here, the given differential equation. Our given differential equation is given as yx minus y times of dy upon dx is equals to x plus 2 times of y. Right. So if we look at this particular differential equation, what we can see, the differential equation can be easily written as dy upon dx is basically x plus 2y divided by x minus y. Now this basically, if we take x common from both the numerator and denominator, I am left out with 1 plus 2 times of x upon y upon x, plus in the denominator is going to be 1 minus y upon x, right? So you can see that this y upon x part is common, right? So therefore this is a problem of homogeneous type, right? So again we assume the same variable v, that is equals to y upon x. So from here I'll get y is equal to v into x. So if we differentiate both the side with respect to x, I'm going to get it as v plus x times of dv upon dx, right? So therefore the advantage of doing this particular part is that you are able to simplify the solution in terms of a variable separable form. So we proceed further with this. So what we'll see over here, we are getting v plus x times of dv upon dx is equals to 1 plus 2v divided by 1 minus v, right? So on further simplifying, you can take v on this particular side and we can just convert it into a variable separable form. Is that, so I can write x times of dv upon dx is basically equal to 1 plus 2v divided by 1 minus v minus of v. So I can simplify it further as 1 minus v, 1 minus v times of, now in the numerator we will have 1 plus 2v minus v plus of v square, right? So that is nothing but it will be simplified as 1 plus, so I'm simplifying and writing over here 1 plus v square, right? So that is what we are getting. Now if you just look at it, it is basically becoming a form of variable separable, right? So proceeding with the solution of variable separable form, so it is just being of the form of variable separable, right? So I can take the dv part with the v, right? So v is basically, in the denominator it will come at v square plus v plus 1, and the numerator it was basically equal to v plus 1, right? V plus, oh, sorry, v 1 minus v, right? So it is basically equal to 1 minus v. Okay, so integration of it and is equal to dx upon x integration of it, right? So that's how we simplify and make it of the form of variable separable form, right? So if we look at this particular part, so this part, the right hand side is going to be natural log of x plus of c, right? But this part is little bit tricky. So what we'll see is that we have to simplify the denominator and the numerator as terms of our differentiation, so that we can solve this integration by just by using substitution, right? So what will I do? I will just assume that 1 minus v is equals to some constant times of, d upon dv of this denominator plus some constant, right? Now if we solve for this, we will basically get a times of 2v plus 1 plus b. Now if we solve both the sides of the equation, we will get value of a equals to, so you can just simply solve it just by equating the variable part v. So we'll get a is basically equal to minus of 1 by 2, and we will get b is equal to, is equal to 3 upon 2, right? So if we get the value of a and b from here, we can simply solve this integration. So this particular integration I'm solving over here. So this particular integration is becoming of the form as a times of v square plus v plus 1 differentiation of this plus b into dv divided by v square plus v plus of 1, right? So we can simplify and get the result as basically this particular part will be equal to a times of natural log of v square plus v plus 1, right? Now the part of integration b upon v square plus v plus 1 is basically of the form, of, like, now we have to simplify this part, right? This part of the integration. So this part of the integration, it is basically 3 upon 2 divided by v square plus v plus 1. Now if you just simplify and make it as a perfect square, what I can make this particular part as a perfect square as v square plus v plus, so I can just simplify and make it a perfect square as v plus 1 by 2 whole square minus of plus of 3 upon 4. So we can simplify the denominator and write like this. Now advantage of doing this that we can simplify it as form of 1 upon x square plus a square. That is nothing but going to give me b times of tan inverse of v plus 1 by 2 divided by 3 by 4, right, plus some constant c. Is it okay? And don't forget that we have to also keep the 1 upon a term, right? So what is the a term over here? A term is basically root 3 by 2 because it is a square, right? So over here root 3 by 2 over here, and then 1 upon a will basically be equal to 2 upon root 3, right? Is it clear to you? Right. So from, because we know that integration of dx upon x square plus a square is basically nothing but simple equal to 1 upon a tan inverse of x upon a, right? Tan inverse of x upon a plus some constant c, right? So if you use this particular formula, then we will get the solution of this particular form, right? So therefore your ultimate solution to this differential equation is given like this. So you have the right hand side as ln x plus c is equal to this particular side where you have the value of a and value of b. That is going to be our final answer. So we are not going to leave the answer in terms of v, but rather we will substitute back as v as y upon x, right? So please don't forget to do this part. Fine. So I hope this part of the solution is clear to you. Okay. So please let me know in the comment, in the chat, if you are clear with the solution. If you are not able to, yeah, hi Nitish, how are you doing? Yes, Nitish, you can tell me your query if you have. Nitish, please mention the problem you are having, or else we can proceed with the next part of the solution. Okay, fine. So this part is clear to all of you, right? So with this, let's move to the next problem. Again, we have another differential equation question. Now in this case, you have to basically find the particular solution with a given initial value problem, right? So again, I'll solve it by the following method. Is that, again, I will write the given differential equation. So you can see that there are mostly repetitive types of problems that are going to be asked in your CBSE examination, right? So the questions are very similar nature. So what you can try to practice is that if you are practicing different types of problems, or many times you are going to basically get a grasp of it, right? So the given differential equation is given as x times of sine square y upon x minus of y whole times of dx plus x times of dy is equal to 0, right? Now over here, if you look at this particular problem, what you see that it is not mentioned explicitly in terms of the dy by dx, right? So our task is basically to simplify it in terms of dy upon dx. So what we can do, we can just simplify this part upon as dy upon dx as, so if you just simplify this, is going to be equal to y minus x sine times of y upon x divided by x, right? So now what you can see, if you take x common from the numerator and denominator, you are going to get the form as y upon x minus sine of y upon x, right? As simple as that. Now again, it is basically of the form of homogeneous form, right? So we can again assume v as y upon x, and then we can write y as v into x, and from here I will get dy upon dx is basically equal to v plus x times of dv upon dx, right? It is clear to all of you. So with this, if I just replace this dy by dx with this part, I'm going to get the form as, so I can just simply write it as dv upon dx x times plus of v is equals to v minus sine times of v, right? Now it is very simple. You can just simply take v and v cancel on both the side, and it is basically the form of variable separable type, right? So you can take dv upon minus of sine v is equal to dx upon x. Now if you just integrate both the sides with respect to the corresponding variable, so we are going to get the solution over here is that this particular thing is basically becoming um, minus of cosec v, right? So that particular solution is basically equal to, so you can just simply see that this is basically becoming cot of y upon x is equals to natural log of x plus of c, right? So this minus part is accounted in itself, right? So I hope you are having no confusion from this part. Just let me check. Okay, let me check. Actually, I missed the square part over here. Right, right. So exactly, I missed the square part over here. So this was basically 1 upon sine square v, that is going to be equal to minus of cos square v, and integration of that is going to be equal to cot of y upon x. So just I am replacing v with y upon x, right? So that is going to be my general differential equation solution, right? But we are also provided with the value of x and y. So at x is equal to 1, y is equal to pi by 4. So I will write at x is equal to 1, y is equal to pi by 4. So with this I will yield the solution as, cot of pi by 4 is equals to c. So from here I will get the value of the constant as, so the constant value is going to come out as minus of 1, right? Please correct me if I have any mistakes. Okay, so this part is clear, right? Uh, okay, I forgot to miss this negative sign, right? Yeah, yeah. So there is a minus 1 over here, my minus sign over here, right? So that's how we get the value of constant as minus of 1. Fine. Now, if we are having this particular value of the constant, so therefore we are in the position to write the particular solution, right? So from the general solution, we find out the value of the constant. So the particular solution will be basically equal to 1 plus natural log of x is equals to, so I am taking this on the, okay, so this minus sign is common, so this is going to be equal to cot of y upon x. So that is going to be a particular solution. So this solution of a differential equation is a equation of any particular curve, right? So I hope this particular part was clear and simple, right? If you have any query, you can tell me in the chat. So I'm looking for your chats. Okay. All right. So you're having no queries, anyone? Okay. So I hope this part is clear, right? With this, let's move to the next problem. So again, you can see I have another CBSE previous year problems. So again, it is again a very simple type. So if you just look at the problems, you can understand that more or less the type of the problem that is basically getting repeated every year is the homogeneous type of differential equation, that is y upon x part, right? So you can see almost in every questions it is basically you are having the homogeneous type and then you are integrating it, right? So it's totally dependent upon your how well are your integration skills are, and then how well are you able to get to the values, right? So that is all what matter, right? So first of all, identify that what type of differential equation you are having, right? So again, we have a differential equation which is mentioned as dy upon dx is basically equal to x times of 2 log x plus of 1 divided by sin y plus y times of cos y, right? So if we just look at this particular problem, we can easily see that it is basically a simple problem of variable separable form. What you can do, you can just separate the variable on the respective side and you can get to the integration easily, right? So therefore, it's a simple form of variable separable. So I'm not solving it properly. So I'm just showing you that how we can solve it. Now the catch is basically it's not a very simple step. The simple step is basically from here to here, right? But the step that involves to solve this particular part is by parts. That is something that you have studied in the part of methods of integration, right? So while you know, if you know the methods of integration, you can easily solve this problem, right? So if we just move further, what we can see, this sin y can be easily written as minus of cos y, but this part integration of y into cos y dy needs by parts to be solved, right? And is equals to, this part is basically 2 times of x into log x integration of that plus integration of x dx. So that is basically x square by 2. So I can simplify and write it as x square upon 2, right? Plus some constant, right? Now it is all up to you how you can solve this by parts. Okay, so I'm leaving this part as a homework. So I hope you will solve this part and come up with the answer, right? So this part I am leaving as a homework. So from here you have to actually solve this problem, right? So to actually apply the by parts rule, I hope you have known the by parts rule till for now, right? So if you don't remember, I can recall you. So whenever you have a two functions u into v with respect to some variable x, so u and v both are the variables of x. So right, so you have u as a first function and v as a second function. So the integration is basically, this particular integration is called as by parts. Okay, and the solution is basically first function into integration of the second function minus differentiation of the first function into integration of the second function and then integration of it, right? So this is basically your by parts. Okay, so just apply this part of the solution and you will definitely get to the final answer. So I'm leaving the final answer over here. So the final answer that I have got while solving is basically y times of sin y is equal to x square natural log of x plus of pi by 2. So you have the given value of the initial condition. So from there you can definitely or easily find out what is the value of the required constant, right? So I can show you that, see how simple questions are basically asked. It's all dependent upon your ability to solve the integration part, right? So in the upcoming this particular lecture, we have been definitely analyzing the different problems or different sets. And in that different problems, what we are analyzing is that the differential equation requires little bit manipulation to solve it in a simplified form, and then we have to basically evaluate the integration part. So mostly the major emphasis is again put on the integration, right? And also I have shown you like how you can basically expect to get full marks by doing the step by step parts, right? Please let me know if you have any query. Okay, yeah, Tanmay, it is very important for your board examinations. Okay, in board examination you can at least expect to have at least more than like 3 or 4 problems in your board examination. That is something that I can guarantee, right? One problem you can definitely get a 1 marker problem from the order and the degree part. So please don't forget to prepare the order and degree of any given differential equation, right? So that is the starting part of the differential equation, right? So from here you will get a 1 marker problem. Okay, you will also get a formation of differential equation problem, right? Formation of differential equation. So that is basically a 2 marker problem, right? So formation of differential equation, and ultimately we will also have solution of differential equation problem, and that will basically be of like 3 or 4 marks, okay, depending upon the integration you're solving. So this is the entire part that you have to study for the differential equation, and yes, it is very important for your board examination. Okay, so if you want me to tell you that what are the most important and prioritized chapter, is that you should prioritize first of all integration, then you should prioritize your differential equation, applications of integrals. You should also prioritize your chapter of applications of derivative, right? So these are some of the very important chapters that are basically have more weightage in the examination, right? Also along with that, I would also recommend you to practice the vectors and 3D geometry. They are very simple. Fine. With this, let's move to the next problem. So again, if you just look at the next problem, what you see is that this particular problem is again a given differential equation of the form as, so if you look at the differential equation, and so from here I'm directly doing the step is that I'm dividing by x square minus 1. So what you can see, it is basically becoming like this. Now, if you try to analyze, this is nothing but the same form of a linear differential equation. So if you recall the linear differential equation, it is basically like this, right? Linear differential equation of the first order, right? Right. So if we just compare on the given coefficient p and q, so we'll get p as 2x upon x square minus 1 and q as this one, right? So from here, we just need to calculate what is the integrating factor. So integrating factor is e raised to the power integration of 2x divided by x square minus 1. So which is very simple. This integration is very simple. Is that you just assume this denominator as some t. Okay. So you assume this denominator as some t. So the numerator is going to be the dt part, right? So this from here you will get 2x dx is basically equal to dt. So we just solve this integration by substitution. So ultimately the integrating factor is going to be equal to integration of natural log of x square minus of 1. So again we ignore the constant because I have told you that we apply the constant at the end, right? From here I will again use the base changing formula. So from here you will get the solution as, so it is basically we change the base, so we get the integrating factor as 1 minus x square minus 1, right? So and we know the solution of a first order linear differential equation is basically y into integrating factor is equal to integration of q into integrating factor dx plus some constant, right? So if I solve this, so the solution will basically be equal to y into x square minus 1 integration of 2x, sorry, 2 divided by x square minus 1 whole square into the integrating factor. So from here this part and this part will cancel out. So from here we get this integration very simple, that is 2 by x square minus 1 dx, right? So again it is an integration of the form of like integration dx divided by x square minus a square, right? So this integration is basically equal to 1 upon 2 times of a natural log of x minus a divided by x plus a plus some constant. So whenever, and one more good habit is basically always to write the formula along with the steps, right? So this will actually show the examiner that you have prepared nicely and they will definitely give you the full marks. Perfect. So ultimately your solution is going to be equal to 1 upon, so this 2 will come out, right? 2 is a constant and this a is 1, right? So 1 up 2 by 2 into natural log of x minus 1 divided by x plus of 1. So don't forget to put the mod plus some constant, right? So from here you get the ultimate solution as, y times of x square minus 1 is equal to natural log of x minus 1 by x plus 1, right, plus some constant c, right? So in this is the required solution of your differential equation. This part is the required solution of your differential equation. I hope if you are following clearly, you understand that what are the most important part, right? So it is again a simple linear differential equation of the first order. What I am doing, first of all, calculating what is the integrating factor. If I calculate the integrating factor, I am just putting this integrating factor into this solution. I know the solution of the first order differential equation is basically y times of integrating factor is equal to integration of the right hand side part with the integrating factor. As simple as that, right? So from here I get the ultimate answer. So in this case no initial condition is provided, so therefore your solution is basically the general solution of the differential equation, right? So with this we come to the end of the discussions of differential equation. So what you can understand is that you can see in solution of differential equation you can mostly assume questions of 3 to 4 marks, and the most important parts are variable separable, homogeneous part where y by x form is there, you assume it as v and proceed to the solution, and then first order linear differential equation. So with this particular previous year problem solving, I made you clear that the questions are not difficult, they are basically conceptual. Okay, so once you're able to find out the separate the differential equation, you can easily solve the part of the integration, right? Is it fine to all of you? Okay, Tanmay, I was able to clear your doubt. Fine. So with this, let's end our session over here. I hope this session was helpful to all of you. So I have mentioned it clearly. So paper analysis was basically is that in solution of differential equation, you can expect to get the form of y upon x part, or you can get the form of the first order the linear differential equation. Okay, now this part is something very crucial, because you can also expect to get questions on JEE mains also. Okay, so I'm putting stars over it to make sure that you have prepared this part nicely, right? And along with that, order and degrees questions are also very important. Okay, they are 1 marker questions definitely coming up. Okay, and formation of differential equation, right? So I hope you will keep these things in mind and prepare for your upcoming examination. All right, so with this, I hope you all do perfectly, and I wish you all good luck.